In the largest heart of southeast France, the Tarn River Valley was once a daunting obstacle, a deep, wind-swept draught that forced travelers into a grueling descent and climb. To bridge this gap, engineers didn't just build a road, they engaged in a direct confrontation with the heavens. The Millau Viaduct is a masterpiece of monolithic grandeur, featuring seven slender masts that pierce the sky, with the highest pier reaching a staggering 343 meters. This makes it taller than the Eiffel Tower, officially the highest bridge structure on the planet. It is a place where the earth seemed to have evaporated, leaving only a thin ribbons of asphalt suspended in the blue. The primary physical adversary at Millau is not gravity, but the wind. The Tarn Valley acts as a natural wind tunnel, where gusts can scream through the drought at speed exceeding 150 km/h. At such height, a traditional, heavy concrete deck would act like a massive saw, risking a catastrophic structural failure. To survive, the bridge used an aerodynamic design inspired by aviation. The steel deck is shaped like an inverted airplane wing, allowing wind to flow smoothly around it rather than pushing against it. It is a brooding, calculated tensions, a structure that stands firm by being aerodynamically invisible to the very guard trying to tear it down. Beyond the wind, the bridge must handle the silent killer of large-scale engineering, thermal expansion. The 2.46 km steel deck is essentially a living organism that breathes with a temperature. On a scorching summer day, the deck can expand by more than 1 meter compared to its length in the freezing winter. If the bridge were rigid, these expansions would generate enough force to shatter the concrete pier. The solutions were a somber masterpiece of flexibility. The top of the massive pier are split into two thinner columns, allowing them to bend and sway with the deck as it grows and screams. It is a state of controlled isolation where the bridge survives by surrendering to the laws of thermodynamics rather than resisting them. The construction itself was a feat of transcendental precision. Instead of building the deck in place, engineers assembled two massive sections on either side of the valley and used high-powered hydraulic rafts to launch them into the void. Each movement was tracked by GPS satellite to ensure that when the two halves weighing tens of thousands of tons, met in the middle of the sky. The margins of error was zero. There is a strategy wonder in the thought of such immense weight being guided with the delicacy of a needle through silk. Driving across the Millau Viaduct on a misty morning is a profound, surreal experience. When the clouds fill the valley below, the pier disappears, and the road seems to float in an infinite, white void. It is a hauntingly beautiful witness to the power of the human mind. The bridge doesn't just cross a valley, it redefines our relationship with the sky. It stands as a reminder that when we master the equations of physics, we don't just build structure, we create gateway to the impossible. The Millau Viaduct is a melancholic poem in steel, proving that even the most terrifying hate can be tamed by a single perfectly calculated lie. For centuries, the English Channel was a liquid fortress, a 33-kilometer stretch of cold, churning sea that separated the United Kingdom from mainland Europe, while the grandeur of the British Empire was built on its naval mastery of the wave. The idea of traveling beneath them was long considered a fever dream. It took over 200 years of failed start and political paranoia before the Channel Tunnel or Tunnel became a reality in 1994. It is a masterpiece of stifling subterranean isolation, consisting of three parallel tubes buried up to 75 meters below the seabed. It is a place where the weight of the entire Atlantic Ocean isn't just a mathematical fact. It is a brooding, physical presence that hangs over every train that passes through. The primary physical adversary of the journal was the crushing hydrostatic pressure of the sea. At its deepest point, the water and earth above exert a relentless force that seeks to reclaim the tunnel. To survive this, engineers had to identify a specific geological layer called the chalk marl. This layer was firm enough to support a tunnel but impermeable enough to keep the water out. However, the geology wasn't perfectly consistent, as the tunnel boring machine (TPMs), mechanical monsters the size of football field, chewed through the earth. They had to be prepared for sudden fall where the sea could come rushing in. To prevent the tunnels from collapsing, the TBM immediately lined the walls with high-strength concrete segments, designed to interlock like a monolithic puzzle, creating a sheet that could withstand the weight of the world without the need for a simple equation to be visible to the passenger. The most staggering wonder of the journal was the meeting of the TBMs. Imagine two giant mechanical worms, one starting in England and one in France, dashing through total darkness beneath the ocean floor. They had to meet in the middle with the precision of a surgeon. If their alignment was off by even a fraction of a percent, they would miss each other entirely, leaving two useless, dead end holes in the air. Using laser-guided surveying and satellite data, they achieved a transcendental feat of accuracy. When the two sides finally broke through in 1990, they were only 35 centimeters apart. There is a hauntingly beautiful irony in that moment. The first time since the age that a person could walk from Britain to France. The atmosphere of the tunnel today is one of profound clinical silence. When you are in the middle of the tunnel, you are in one of the most isolated places on the planet. There is a stifling gloom outside the train windows, a darkness so absolute it felt like a physical barrier. The engineer also had to solve the Piston effect, the massive buildup of air pressure caused by high-speed trains moving through a narrow tube. To prevent the air from acting like a solid wall that would stop the train in its track, they built relief dock to balance the pressure, allowing the air to flow around the cars. It is a somber masterpiece of fluid dynamics, ensuring that the speed of modern light can coexist with the heavy Asian stillness of the seafloor. Today, the Channel Tunnel stands as a melancholic witness to the power of connection. It is a superstructure that defies the curse of the sea, turning a terrifying barrier into a 35-minute commute. It serves as a reminder that the most significant boundary in our world, whether they are made of water or politic, can be bridged by the relentless applications of humans will be the courage to reach into the abyss. On the bank of Yangtze River, humanity has constructed a concrete behemoth so massive that it doesn't just dominate the landscape, it interferes with the very dynamics of our planet. The Three Gorges Dam is the world's largest hydroelectric power station, a 2.3-kilometer long wall of steel and stone rising 60-story high. It is more than just an energy plant. It is a monolithic masterpiece of ambition, where once unruly river has been forced into submission to power a nation. But the true physics-defying legacy of this dam isn't found in the electricity it generates, but in the staggering shift of planetary mass it caused. The most mind-bending physical reality of the Three Gorges Dam is its effect on Earth rotation. When the dam is at full capacity, it holds back an incredible 42 billion tons of water in the reservoir stretching 600 kilometers. Scientists at NASA calculated that by concentrating such a colossal mass of water so far from the Earth's axis, the dam actually increased the planet's movements of inertia. Think of a finger skater spinning on ice. When they extend their arms, they slow down. By effectively extending the Earth's mass, the dam slows the planet's rotation enough to increase the length of every single day by 0.06 microseconds. It is a staggering wonder that reminds us of our terrifying power. We didn't just build a dam, we slightly adjusted the clock of the universe. From an engineering perspective, the dam is a gravity dam, meaning it relies almost entirely on its crushing weight to stay in place, while other dams might use arches to distribute force. The Three Gorges Dam simply uses its own mass to counteract the sheer hydraulic pressure of the Yangtze. Where is the protein tensions in this balance? Millions of tons of water are constantly trying to push the wall over, but the dam is so heavy that the law of friction and gravity render it immovable. It is a somber masterpiece of equilibrium where every cubic meter of concrete was placed to serve as an unyielding shield against the fury of the river. The atmosphere on the site is one of the overwhelming soaring grandeur. When the spillways are open and the water rolls out in a thunderous spray, you can feel the vibration deep in your chest. However, beneath this display of power lies a profound, melancholic silence. To create the reservoir, over 1,000 cities and villages were submerged, and millions of people were displaced. A world of ancient history now lies evaporated beneath the surface, replaced by the dark, still water of the reservoir. There is a haunting sorrow in the trade-off. To light up the future, we had to draw a piece of the past. Today, the three gorgeous dam stands as a hauntingly beautiful witness to the Anthropocene, the age where human activity is a geological force. It is a melancholic poem written in concrete, proving that our engineering has reached a scale where the earth itself must react to our presence. As the turbines spin and the water level raise, the dam remains a silent sentinel, a reminder that the price of modern grandeur is often the permanent alteration of the world we call home. Rising from the sun-scorched sands of Dubai like a silver needle, the Burj Khalifa is a structure that shouldn't, by the traditional rule of the 20th century, be able to stand at 828 meters tall, nearly a kilometer into the sky. It is more than twice the height of the Empire State Building. It is the ultimate masterpiece of vertical ambition, a place where the grandeur of human ego has literally punctured the ceiling of the cloud. But to reach this height, engineers had to do more than just stack steel. They had to solve a later physical riddle: how to prevent the wind from shaking the world's tallest building into pieces. The primary enemy of any skyscraper isn't gravity, it is wind. As wind hits a tall, flat building, it creates vortex shading, swirling eddies of air that alternate from side to side, creating a rhythmic vibration. If the vibration matches the building's natural frequency, the structure can begin to sway violently until it snaps. To defeat this, the Burj Khalifa was designed to conceal the wind. Its Y-shaped plan and towering, staggered tier mean that at every level, the building has a different shape. The wind never finds a consistent surface to push against, and the vortices are broken up before they can ever become organized. The construction was a staggering wonder of logistics and chemistry. To build the core, engineers had to pump high-pressure concrete to a height of over 600 meters, a world record. Because of the extreme desert heat, the concrete had to be mixed with ice and pumped only at night to prevent it from setting too quickly in the pipes. There is a budding tension in this process. If the pump fell or the mixture was slightly off, the concrete would harden inside the pipes, effectively killing the construction process. Is what a somber masterpiece of timing, where the difference between the record-breaking spy and the ruined pipe was a new degree of temperature. The atmosphere at the top of the bird is one of profound ethereal isolation. Up there, the temperature is significantly lower than at the base, and the air is noticeably thinner. On some days, the building is a hauntingly beautiful witness to a sea of cloud, where the rest of Dubai is completely evaporated from view, leaving only the silver tip of the tower floating in a white void. There is the melancholic poem in this height. It is a sanctuary built for those who wish to escape the earth, that it remain anchored by 110,000 tons of concrete in the deep desert soil. Today, the Burj Khalifa stands as a solemn monument to the fact that gravity is no longer a cage. It is a reminder that with enough mathematical precision, we can build a ladder to the star. However, it also serves as a haunting reflection of our era, a simmering, fractured glass giant that requires constant energy to keep the desert heat at bay. It is a masterpiece of defiance, proving that even in the harshest environment, the human spirit will always try to reach just a little bit higher than the laws of physics should allow. In the crowded geography of Japan, where mountains dominate the landscape and every square inch of flat land is a premium, the city of Osaka faced a seemingly impossible problem. They need a massive international airport, but there was nowhere left to put it. The solution was as bold as it was terrifying. If there's no land, we will build it in the middle of the sea. Kansai International Airport is the world's first ocean-based airport, a 20 billion man-made island that is a staggering wonder of civil engineering. But building an island is the easy part. The real physics-defying challenge is keeping it from being evaporated by the soft, unstable seabed beneath it. The primary physics adversary here is settlement. The airport sits on a layer of reclaimed land, millions of tons of rock and sand, resting on a seabed of soft, silty clay that is as unstable as Westbound. From the moment the first stone was dropped, the island began to sink. Engineers knew it would settle, but the earth has other plans. The island sank faster and further than anyone predicted. There is the brooding tension in the design of the terminal building itself. It is a monolithic masterpiece over a mile long, designed with the graceful curve of an airplane wing. But beneath this beauty lies a mechanical world. The terminal is supported by over 900 massive steel pillars, each equipped with its own hydraulic jack system. The jacks are the heart of the structure's survival. As the island sinks unevenly, sensors detect the slightest steel in the building. Engineers then jack up the individual pillar and insert thick steel plates to keep the floor perfectly level. It is a somber masterpiece of a constant adjustment, a building that is effectively working on a sinking floor to stay upright. To date, the island has sunk more than 12 meters, far more than the height of the three-story building that the airport remained operational. It is a haunting witness to the fact that stability is not always about being rigid. Sometimes it is about the ability to move with the earth. The atmosphere of Kansai is one of profound high-tech isolation. It is a gateway to the world that is connected to the mainland only by a single 3.7-kilometer bridge. In 1995, the airport faced its ultimate test, the Great Hanshin earthquake. While the city of Kobe was devastated, Kansai, located just 20 miles from the epicenter, remained unscattered. Its floating nature allowed it to observe the shock wave that shattered land-based structure. However, a new melancholic threat looms, rising sea level and increasingly violent typhoons. In 2018, a massive storm flooded the runways and crashed a tanker into the bridge, cutting the islands off from the world. Today, Kansai International Airport stands as a sovereign monument to human resilience. It is a melancholic poem written in steel and salt, a reminder that we can conquer the ocean, but we must never stop fighting to stay above it. It serves as a reminder that the most impressive structures are often the most fragile, requiring a never-ending dance with the element to keep from being reclaimed by the deep. It is a masterpiece of defiance, proving that even on a foundation of mud, we can build a gateway to the stars. Buried 100 meters beneath the rolling countryside on the border of Switzerland and France lies a machine so immense and so complex that it evaporates our conventional understanding of the physical world. The Large Hadron Collider (LHC) is not just a piece of equipment, it is a 27-kilometer circular tunnel of extreme technology, the largest and most powerful machines ever built by human hand. It is a monolithic masterpiece of curiosity, designed to recreate the conditions of the universe just a fraction of a second after the Big Bang. Here, we don't just study physics, we smash it together to see what inside. The first physical limit the LHC defies temperature. To guide beam a proton at nearly the speed of light, the machines use thousands of superconduction magnets. For these magnets to work, they should be cooled to a temperature of 1.9 Kelvin, which is about minus 271 degrees Celsius. This makes the interior of the LHC colder than the vast reaches of deep space. There is a stifling frozen gloom within the tunnel pipes, where the world's largest cryogenic system pumps liquid helium to keep the machine from melting under its own electrical power. It is a somber masterpiece of thermal management, creating a ribbon of absolute winter that stretches for miles beneath the earth. The second limit is speed and vacuum. Inside the collider, two beams of particles travel in opposite directions at 99.9999991% the speed of light, completing over 11,000 laps of the 27-kilometer ring every single second. To ensure the particles don't hit a single molecule of air, the interior of the beam pipes is pumped down to an ultra-high vacuum. The pressure inside is lower than the pressure on the surface of the moon. There is a broadening empty tensions in these pipes. They are the emptiest place in the solar system, a void created by man to let light speed ghost dance. The atmosphere of the LHC is one of profound scientific awe. The particles are crushed together at 4 points around the ring, where massive detectors like ASLRs and CMS machines that size of 7-story cathedral act as the world's most powerful digital cameras. They record 600 million collisions every second. There is a hauntingly beautiful witness in the detector. They are monuments built to see the invisible, searching for the God particle, the Higgs bosons, and the secret of dark matter. When the beams are on, the energy concentrated in those tiny collision points is so intense it creates temperature 100,000 times hotter than the center of the sun. The LHC is a masterpiece of defiance. It proves that our hunger for the truth is stronger than the limit of our engineering. We have built a machine that can look back to the beginning of time. Today, the Large Hadron Collider stands as a soaring monument to global cooperation. It is a melancholic poem written in madness and data, reminding us that we are just a small species on a blue dot, yet we have built a time machine to understand how everything began. It serves as a reminder that the most significant superstructures are not always the ones that reach for the sky, but the ones that reach into the very fabric of reality itself. On the border between Brazil and Paraguay, across the relentless Paraná River, stands a structure so massive it redefines the term heavy industry. Itapu Binacional is the hollow gravity dam that stretches for 7.7 kilometers, a wall of concrete so dense and so high it looks like a man-made mountain range. It is a monolithic masterpiece of endurance, containing enough concrete to build 210 football stadium or a bridge connecting Brazil to Portugal. But Itapu is not just about size, it is a staggering wonder of hydraulic engineering that captured the raw, kinetic energy of one of the world's most powerful river systems, turning a liquid curse of seasonal flooding into a storage sort of light for two nations. The primary physical adversary of Itapu is the unimaginable pressure of the Paraná. The river flow is so immense that engineers couldn't simply block it with a solid wall. The pressure would eventually find a weak point and shatter it. Instead, they designed a hollow gravity dam. By making a dam hollow, they used less material while maintaining the same massive footprint, allowing the structure to use its own crushing weight to push back against and river. There is a brooding tension in the air near the base of the dam. You can feel the vibration of millions of tons of water pressing against the concrete, a silent war of forces that has been raging since 1984. The heart of this beast is in 20 massive turbines. Each one is so large that a house could fit inside the intake pipe. When the river is high and the spillways are opened, the water shoots out at a rate of 62,000 cubic meters per second, 40 times the average flow of the Iguazu Fall. Nearby, the atmosphere is defined by stifling, thunderous roar that you don't just hear, but feel in your marrow. It is a hauntingly beautiful witness to human power. For the moment, the natural world chaotic energy is evaporated and replaced by a clinical high-voltage hum that powers nearly 90% of Paraguay and 50% of Brazil. However, beneath this display of storage grandeur lies a profound, melancholic silence. To build Itapuí, the Guayra Falls, one of the world's most powerful waterfalls by volume, were completely submerged and eventually dynamited to allow for the reservoir. A natural wonder that has existed for millions of years was sacrificed for a man-made one. There is a haunting sorrow in the trade-off. To create the world's most productive clean energy source, we had to erase one of the Earth's greatest natural particles. It is a melancholic poem in concrete, a reminder that our greatest triumph often requires an irreversible change to the world we inhabit. Itabu is a masterpiece of defiance. It's proof that we can harness the very vein of the earth to fuel our future, even if it means leaving a part of our natural heritage behind in the deep. Today, the Itapu Dam remains a storage monument to international cooperation and engineering audacity. It is a reminder that we are no longer at the mercy of the element. We have learned to channel the word fully into a steady, reliable pulse. As the sun sets over the massive reservoir, the dam stands as a silent, grey titan, a hauntingly quiet protector that keeps the light on for millions, anchored by the weight of its own history and the relentless flow of the Parana. Deep beneath the snow-capped peak of the Swiss Alps, humanity has carved a line through the very root of the mountains. The Gotthard Base Tunnel is the world's longest and deepest rail tunnel, a 57-kilometer subterranean passage that bypasses the treacherous, winding mountain pass above. It is a monolithic masterpiece of transit, creating a flat, high-speed connection through the geographical spine of Europe. But to achieve this, engineers had to journey into a realm of stifling primeval heat and bone-crushing pressure, where the mountain itself seemed to resist being opened. The primary physical adversary of the Godhead was the overburden, the sheer weight of the 2,300 meters of solid rock brushing down from above. At this depth, the mountain is not a static object, it is a living, shifting mass of immense energy. The pressure was so intense that the rock would open, burst, or deform, closing is on the tunnel boring machine like a slow-motion trap. To survive, engineers used a flexible lining system, allowing the tunnel to deform slightly before being reinforced with high-strain concrete. There is a broadening tension in the design. You are traveling through a hole that the mountain is constantly trying to heal by crushing it shut. The second limits what geothermal heat. As you go deeper into the earth crust, the temperature raises. Inside the Gotthard, the rock face reached temperature of 46 degrees Celsius, 115 degrees Fahrenheit. Without a massive, constant ventilation system, the air would have been unbreathable and the equipment would have failed. Thousands of workers spend years in a stifling, humid gloom, working in each hour shift in what felt like a high-pressure sauna. It is a somber masterpiece of life support, where every breath of fresh air has to be mechanical delivered from a mile away. The atmosphere of the tunnel today is one of clinical high-speed isolation. When a passenger train enters at 250 km/h, the world above, the glacier, the Alpine meadow, and the fresh mountain air simply evaporate. You are encased in a concrete tube, separated from a crushing weight of the earth by only a few meters of reinforced lining. There is a hauntingly beautiful witness to this engineering in the multi-function station, located deep inside the mountain, emergency stop area that look like something out of the futuristic space station, carved into the cold gray granite. The Gotthard is a masterpiece of defiance. It's proof that we no longer need to climb the peak to conquer the world. We have learned to peer the hurt of the itch itself. However, beneath the soul-rich grandeur of the finished project lie a profound, melancholic silence. The tunnel took 17 years to complete and cost the life of 9 workers who perished in the dark, miles from the suns. There is a hunting shuttle in the serify required to shave an hour off a commute near the North Portal, a memorial stand for those who die, a reminder that the price of our modern superstructure is often measured in human spirit and physical endurance. It is a melancholic poem written in stone and steel, a gateway that connects nations but remain forever anchored in the heavy, silent dark of the mountain core. Today, the Gotthard-based tunnel stands at a soul-range monument to swift precision. It is a reminder that the shortest distance between 2 points is often the one that requires the most courage to build. As you emerge from the darkness into the bright light of the valleys, the staggering wonder of the journey lingers, a reminder that we have truly learned to walk and ride through the impossible. While the other structures on this list are anchored in the crushing weight of Earth gravity, our second entry exists in a realm where up and down have no meaning. The James Webb Space Telescope is the most complex, expensive, and fragile machine ever launched into the void. It is a monolithic masterpiece of precision, a golden eye precision 1.5 million kilometers away from Earth at a stable point in space called L2. Is it not just a telescope? It's a transcendental time machine designed to capture the ghost of the first star that flickered into existence 13.5 billion years ago. To achieve it, it must defy the most fundamental limit of light, heat, and mechanical reliability. The primary physical adversary of the GWST is thermal radiation. To see the incredible faint infrared light from the dawn of time, the telescope must be kept at temperature near absolute zero, specifically below minus 223 degrees Celsius. However, it also has to face the relentless heat of the sun. To solve this, engineers created a 5-layer sunscreen the size of a tennis court, made of a material called cotton. This sheet is the sunken masterpiece of thermal isolation. While the sun-facing side is hard enough to boil water, the shadow side, where the delicate gold plate mirror sits, is cold enough to freeze nitrogen. This is a breathing tension in this thin, silvery barrier. It is the only thing standing between the telescope's survival and its immediate evaporation by solar heat. The second limit is the physics of deployment. Because the telescope were too large to fit into any rocket, it's hard to be folded like a piece of cosmic origami. Once in space, it's hard to undergo a week-long unfolding process with 344 single-point fellow. If any one of those boat, couple, or motor has jammed, the $10 billion project would have become a silent, drifting piece of space junk. There is a staggering wonder in the fact that this intricate dance of mechanical part was executed perfectly in the absolute silence of the vacuum, millions of miles from any human hand that could fix it. It is a hauntingly beautiful witness to our ability to build machines that can perform miracles in the dark. The atmosphere surrounding the GWST mission is one of profound existential awe. Unlike the Hubble, which orbits close to Earth, the Webb is storage isolation far beyond the reach of any repair mission. It sits in the permanent midnight of Earth's shadow, staring into the deepest corner of the universe. The image is sent back, swirling nebula, ancient galaxy, and the birth of suns are a melancholic poem written in light. They remind us that we are a tiny species on a small rock, yet we have built an eye capable of looking back to the moment the universe began breathing. Webb is a masterpiece of defiance. It's proof that our curiosity can reach further than our body ever will. We have sent a piece of ourselves into the deep dark to ask the oldest question of all: where did we come from? Today, the James Webb Space Telescope stands as the ultimate monument to human ingenuity. It serves as a reminder that the most significant superstructures are no longer built of just stone and steel, but of light, gold, and the courage to look into the abyss. It is a hauntingly quiet sentinel, floating in the void, forever changing our understanding of reality as it captured the very first flicker of the cosmos. At the summit of our list stands a project so radical it feels as though the boundary between science fiction and reality has completely evaporated. The Line, part of the Neom megacity project in Saudi Arabia, is not just a building, it is a conceptual revolution. Imagine a single continuous skyscraper city stretching 170 kilometers across the desert, standing 500 meters tall but only 200 meters wide. It is designed to house 9 million people in a footprint that is the mere fraction of a traditional city. This is the ultimate monolithic masterpiece of defiance, a mirrored silver blade slicking through the sand, challenging every established law of urban planning, ecology, and structural physics. The primary physical adversary of the Line is the environment itself. To build a 170-kilometer long grassware structure in one of the hottest deserts on Earth is to invite a thermal catastrophe. A glass box of this scale should, by all right, turn into a giant greenhouse, cooking everything inside. To defy this, engineers have proposed a natural ventilation system powered by the chimney effect. By using the height of the structure and the temperature differential between the shade interior and the sunbaked exterior, the city is designed to create its own microclimate, maintaining a constant, comfortable temperature year-round without the massive energy cost of traditional air conditioning. It is a brooding, calculated gamble on fluid dynamics, a city that breaks like a living organism. The second limit is zero-gravity urbanism. In the Line, the concept of horizontal travel is largely abandoned in favor of verticality. Schools, offices, parks, and homes are stuck on top of each other, allowing residents to meet all their daily needs within a 5-minute walk. For longer distance, a high-speed rail buried deep in the structure is intended to travel the full 170 kilometers in just 20 minutes. There is a staggering wonder in this level of density. It seeks to eliminate car and road entirely, evaporating the noise and population of the 20th century city. However, there is a broad intention in the sheer structural integrity required to maintain a perfectly string like over such a distance, accounting for the curvature of the earth itself. The atmosphere of the line is one of profound sovereign isolation. The exterior is clad in mirror, designed to reflect the desert and the mountains, making the massive structure nearly invisible from a distance. It is a hauntingly beautiful witness to human ambition, a mirage that is actually a titan of steel and glass. Yet, beneath the grandeur, there is the melancholic debate about the cost of such a dream. Critic and ecologists point to the potential cost of such a barrier on migratory bird and local wildlife. It is a melancholic poem written in Miro, a sanctuary for millions that simultaneously cut a landscape in two. The lie is the ultimate masterpiece of defiance. It is a declaration that the cities of the past are obsolete and that humanity is already to live within a single, perfectly calculated line between the earth and the sky. Today, the line remains a storage monument to the impossible, whether it's become a flourishing utopia or a hunting ground of over-ambition. It has already achieved its goal. It has forced Earth to rethink what a structure can be. It is the final frontier of engineering, a place where the logic of physics is pushed to its absolute breaking point to create a new way of existing on this planet. As the first module raised from the sand, the light stands at a silent, simmering promise that our future will look nothing like our past.